Finding inverses of one-to-one functions. Now, when finding the inverse of a function when it is already one-to-one, the inverse of the function will also be a one-to-one function, and therefore you can just straightforward find the inverse, and that will be a one-to-one function also. And if you've looked through the video of all of the types of functions, the summary that I've made in the table form, you will already know that most of the functions that you do are one-to-one function, with the exception being the quadratic function, the parabola, and the cubic function. Those are more to one functions. The rest will be one-to-one functions. So if I find the inverse of a one-to-one function, literally there's two things I must do. The first thing is swap the y and the x values, or all of the y values become x's, and all of the x values becomes y's in the equation. You just swap them. And then for the second thing, you just rewrite the equation in the form y is equal to. Alright, so for example, say for instance I have the straight line y is equal to 3x minus 4. This is a function given to me, and they say the function that, right, the function, so that y is that, right? Then what I want to do to find the inverse of this function, I'm going to swap the y and the x value. So this becomes x is equal to 3y minus 4. And then I just rewrite it in standard form. So I want y alone again. That's all I do really. So to get the y alone, I'm going to take over the 4 and then divide by 3 both sides. Like that. Right, and if you simplify this even a little bit more, I just write x over 3 and 4 over 3 as separate fractions. X over 3, or a third x, plus 4 over 3. You can see that the inverse of a line function will also be a line function. Right, let me do another example of a line function there. So say for instance I've got a function given to me y is equal to a half x minus a quarter plus a quarter. Half x plus a quarter, right? Then the inverse of the function, there's two things I want to do. I want to swap the x and the y values. The rest of the equation stays the same. And then I just want to get y alone again. So I've got x minus a quarter is equal to a half y. And then I can just multiply throughout by 2 to get rid of this half. So I've got 2x minus a half is equal to y. Or you can just write it the other way around. Y is equal to 2x minus a half, like that. Right, so that's fairly simple, and you can see again I've got a straight line, and the inverse of my straight line will also be a straight line function. Alright, so that is how the straight line one-to-one function works. Very straightforward, very easy. Let's look at some parabola examples. So say for instance I've got y is equal to 2 over x plus 6. Right, for my function, then the inverse of this function will be x is equal to 2 over y plus 6. And then I've got, let's multiply with y throughout. So I've got xy is equal to 2 plus 6y. I want to get y alone, but now the fraction is bothering me, so I just multiply with a y throughout. Then I'm going to group all of my y terms on this side. minus 6y is equal to 2, and I'm just going to factorize the y out as a common factor, like that. And then I can divide by this x minus 6 bracket both sides, so that I have this. Alright. Okay, this is simple, straightforward algebra. There's two things you do. You swap the x and the y, and then you just solve for y again. So just get the y alone, manipulate the equation until you have y alone. Right, let's look at another example of a parabola. So say for instance I've got y is equal to 3 over x minus 3 plus 2, like that. Then for my inverse, I'm just going to, let me do it here. For my inverse function, I'm just going to swap them. So I've got x is equal to 3 over y minus 3 plus 2. And then I multiply with y minus 3 throughout. So I've got x times y minus 3 is equal to 3 plus 2 times y minus 3, like that. And then I just want to get rid of the bracket, so I'm going to multiply out x, y. X times minus 3 is minus 3x, 3 plus 2y minus 6, can you see? 2y minus 6, if I multiply this 2 in. And then I just again gather all of my y terms together, like this. And all of the rest, 3x, 3 minus 6, and minus 3, like that. Just gathered the xy, took the 2y over, it becomes negative. 3 minus 6 is minus 3, and I just brought this negative 3x over so that it's positive 3x. And then this is y x minus 2 is equal to 3x minus 3. And then if I divide by x minus 2, I've got 3x minus 3 divided by x minus 2. Alright, and this is a bit of a complex equation, but you can really just leave it like that. As long as you have y alone, that's all you really want to do. Right, okay, so that's the inverse of my function. That's how that works. Let's quickly look at the exponential function and the log function. So say for instance I've got y is 2 times 4 to the power of x, like that. Very simple exponential function. If I want to find the inverse of this function, yet again I just swap the x and the y value, and then I must get x alone. Now I must get y alone. If y is in the exponent, I'm actually going to have to use logs. Let me just divide by 2 both sides first. So I've got half x is 4 to the power of y, or x over 2. And then I've got y is equal to log with a base of 4, and then a half x, or x over 2, like that. And then you can use your log laws to just simplify this a little bit, but you can really just leave it like that also. Okay, so let's look at another example like this. Say for instance I've got y is 2 times 4 to the power of x. minus 4 like that. Alright. Then I can just really, for the inverse function yet again, I can just swap the x and the y values. And then I will have x plus 4 is equal to 2 times 4y. And then I divide by 2 throughout, so I've got x over 2 plus 2 is equal to 4 to the power of y. Right, and then again my y will be equal to log with a base of 4 of that x over 2 plus 2, like that. And you can really again just leave it like that as long as you have y alone. From there on, if you need to sketch this function, you can just substitute a few values for x and see and go and plot them. So you can really leave it like this for now. Alright, so that is what I do with finding the inverses of functions. And yeah, that is one-to-one functions. For the more-to-one functions, that is where the restrictions come in, and that is most probably the things that you are worried about. That I will do in the next video, is the inverses of more-to-one functions.